All right, people. I'm down to my last layer of 20 gauge, and I've decided that this is not enough wire to run reed switches effectively without resistance. So I'm gonna add like a little ball of 32 on the end here. No, this end, and that's gonna add resistance just in the coil, and it's gonna give us more magnetic field.
Magnetic.
I've never done it like one on top of the other before. It's always been wrapped together. So this will be interesting. I'm gonna do one and we're gonna test it. So this last one isn't as uniform as the first three, which is okay. But you can kind of see like the one underneath here was nice and uniform,
Mm-hmm.
at least up until the tape. Then it got a little bumpy. But this one's all right. It's not perfect. But you can kind of see where I'm at. And this is actually one of the nicer ones. Turned out pretty good because I just taped the ends and I left the middle like untaped. It's turning out pretty smooth. Oh, excuse me. It's turning out very nice. And these cores are phenomenal. I mean, it's just a single core, but it's nice.
Wow.
3/4 of an inch, 3 inches in length.
3 incher.
Yeah. So when we get this down to the end, we're going to tape it off. We'll have our two ends. But then we're going to add the 32 and we'll have two more ends which will hook in series with these ends. And then we'll have just a bigger coil which will reduce the stress on the reed switches.
Hey everybody, welcome to the channel.
Hello, hello.
Do you know anything about harnessing atmospheric electricity?
Maybe second-handedly, I don't know offhand. No. Um,
And
I mean, I think that stuff happens all the time with what I'm doing. I don't ever pay any attention to it. I know Tesla coils are good for harnessing environmental energies.
yeah, I like that Tesla coil you got.
But this is not a Tesla coil. um, I always thought is like the environment is what's really moving. Like it's moving all around us. And I think it's the only way that you'll be able to do faster than light travel without being totally incinerated is if you have it all come to you. Instead of you going to it, you have it all come to you. Only way it's going to work. And if that's the only way it's going to work, you got to start basing it on that premise, the faster than light travel, on the fact that it's the light that's doing the traveling. Like, it's the environment So I don't know, like it's what makes wormholes possible. um, Being able to take the environment on that end of the wormhole and bring it to you on this end of the wormhole with like the time dilation in the wormhole makes it immediate. So it's like you're bringing it all to you instead of you going to it. I know that's probably not what you're talking about, but that's my opinion on that.
Nice. John, if you're still here, do you know anything? Do you know anything about it? Have you ever heard of Madman Markham?
I have not. I don't do my homework. I wish that I knew more, but I think I'd be much farther along if I knew more. It's got to be the hair, right?
Hey everybody, welcome to the channel.
Hey, hey.
We're hand spinning up some coils with cores for pulse motor. Drop a like and subscribe if you like this kind of content.
Drop a gift if you appreciate with a gift. I appreciate your appreciation without a gift as well. I'm not trying to say anything like that, but I do appreciate public displays of affection in that regard, gift wise. All right, we got our two ends. This is high temperature 22 gauge. All right, where did I? There it is. All right. So I believe this goes up to 200 and something other degrees. It's higher than the standard 155. And it goes up to 220. Oh, this is an evil trick.
He's like, no, not the hair. He made a big version of the Jacob's ladder.
Oh, that's pretty cool. I like Jacob's ladder. Was it a spiral Jacob's ladder or was it just the one that goes like that?
He said, look it up.
Oh, okay. All right, straight.
But we got the name. Thank you.
I'll get that.
And it's Markham.
Markham. Markham.
Yeah, COM.
Okay. So I'm marking off the front or the center. So this is where I started it. Okay. Voila. 4 layers of 20 gauge. I didn't even count the turns. I'm not gonna count the turns.
Yeah, that was painful to watch. Thumb cramps and stuff.
Yeah, I didn't. I just made it 4 layers. You could probably find out how many turns if you did that math. It's 3-inch bobbin with looks like about a half an inch, like quarter-inch on each side where the core is sticking out. So it's 2.5 inches at 4 layers. And then you just got to find the diameter of the wire, and there's your equation. But I'm not gonna do it. Na, na, na. thing is beautiful. I mean, it's not perfect. Like up here, it's a little spread out, but this will pound really hard. All right, let's get the 32 gauge. We'll do red. And I'm going to kind of count the turns with this one. All right, so we'll thread it out like this. Need that tape roll again. Goodness. So we want our ends to be kind of like uniform. Same length, basically. We'll tape it up here.
And that's a 32 gauge he's taping on there. Let's see if I can. Oh, sorry.
What?
It's not going. I'm trying to zoom in and it kept on going in and out.
Oh. All right.
He said the V-shaped one, Jacob's ladder.
Okay.
Hi, LS3. How's it going? Welcome to the channel.
Hello, hello.
Hey, Yanni, how's it going?
Yanni.
We are building for sure.
All right, so I think, yeah, counterclockwise. We're just gonna wrap this around.
And that's this right here.
Oh no. See, this is why I don't count the turns. I was trying it, but especially with the 32, man, it's so easy to go over the edge. And if you go over the edge, you're gonna lose your reps.
Yanni said the electromagnets. This will be epic. Awesome. I can't wait to see.
All right, so we're wrapping the 32 so that the reed switches can handle the 20 gauge coils. It's like an added resistor on the end, but it will increase the magnetic field as well. So it's not just a resistor, it's part of the coil too. It's going to be awesome, like he said. We're just going to get a nice little ball on the end here. And then we're going to hook them up in series. And then we're going to test it. Make sure that it works the way I think it should. We're not going to go pretty much past where it is right now because it'll fall right off. All right.
Thank you for the likes, everybody.
Appreciate you. Thank you very much. I'm glad we could all get together tonight. We are moving a little bit closer to the edge here, and it's working out. So
Josh says it's good to be here.
awesome, Josh. Thank you. Appreciate you. Glad I'm not holding the camera tonight, honestly. I get to use both my hands to do something pretty neat. So what we don't want to have happen is it go longer than 2 inches or wider than 2 inches in diameter. Right now I think we're at about an inch. So we're well within. I don't want to do too little for it to make a difference. I want it to make a difference in how much voltage we can put in the system without it frying itself. That's why I'm doing this. Because the 24 layers of 20 gauge on a reed switch, instantaneous like fryage. It's gonna burn out every time. It's gonna pull like 10 amps and just burn out. So
Hi Grover, welcome to the channel.
hello.
Josh says that Einstein dismissed the ether theory in regards to atmospheric electricity. So, and that original question came from John. I think he did leave though. How's it going, Tesla?
I'm just saying, man, you try to make anything that isn't light go as fast as light, and it's gonna evaporate. It's just gonna disappear. So I don't know about that. I think you can bring everything to you without needing to go to it.
Welcome to the channel, Rye.
Hey, Rye, what's up? How you doing?
We have a Spartacus thing going on right now.
All right. So does that look like enough, chat group?
We're trying to get a ball of the red stuff on the end.
Let me know. I mean, does that look like it's enough to act as a secondary coil to reduce stress on the reed switch? I mean, any length of 32 would do, but I think this is getting close to being enough.
Oops, sorry. The cameraman is learning how to zoom in. King says nope. I don't. So he's like more. Yeah.
Yeah, definitely. I feel like you're right, King. I gotta do more. Maybe even make it the full length of the coil here instead of just the tip. That's what I'm kind of wondering if I should do, because it's gotta stay within certain parameters.
He's saying close. He's saying almost though. You're close.
Okay. Good.
We're doing good, Ryan. Thanks for welcome to the channel.
All right, we are going to test this and make sure that it's good. I just don't want to cut the wire before it's long enough, because that's a whole nother. Then we have 2 series circuits. I mean, we can continue the length, but then we got to like hook it all together with clips and stuff.
You're right.
And that just won't work.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale's Pulse Motors.
What's up? It's Papa Bale in your house.
Drop a like and subscribe. We appreciate you. Thanks for the like.
That's pretty tight wrap too. I don't know. Maybe that is enough. Or maybe we should make one here and one down at this end.
Well, let's get some data.
Okay. I'm going to have to tape it off.
Or were you planning on cutting it and then putting one on the other end? Or doing it all?
Either way. I mean, if
Okay.
we test it now, I have to
Cut it. Okay. Because I think it would be advantageous to test it with one side and both
But yeah.
So, but you need one with one side to be able to test
What
it.
I'm saying is that as soon as I mean, we can do it anyway. I think we're going to cut it though,
Okay.
for sure. And then we can clip it together if we need to, tape it together. You know, make it a really small connection.
Yeah, just make sure it's contacted.
Yeah.
Yeah.
Not all this glorious stuff that I'm used to doing. All big and glorified. See, look what happened.
Oh, it popped out.
Just 2 wraps popped out, but that's enough to, you know, get snipped. So I'm going to have to take over that and...
King says you got this, man.
No, the uniformity isn't really an issue. Some people might disagree with that, but I think this is just fine. All right. See, but I gotta leave that core material sticking out the side. I think we got it though. I think we got it. All right, so we got our beginning. We're gonna take this off first because these are gonna be hard to differentiate where the start point is if I cut it now.
How's it going, Mike? Hey, Joshy, welcome to the channel.
Hello, hello. All right, let me get the tape.
Mike Does has arrived.
Hey, Mike.
We're making a coil for pulse motor.
All right.
Pulse motors over here.
Well, this one is for a special pulse motor.
For a special pulse motor.
And I just added the 32 on the end there to increase the magnetic field a little bit, but also to add a little bit of resistance so that the reed switches won't fry instantaneously.
So Joshy doesn't know about pulse motors. You want to give him a quick introduction?
But I will, let me think here. Pulse motors. Yeah, it wasn't. That's a curveball for me right now. I don't know.
Electromagnetism. Magnets.
Brushless DC motors.
Brushless DC motors. Power inputs. You know, the wires are the cores.
And I've been doing this for like 3 years, and that's a curveball.
That was
awesome.
That was a brain fart, man. Straight up.
Oh no.
You're good. And he does all, most of it by hand, purchases some stuff, and most of it's by hand now. So
actually, I want to do this leveled off. All right.
nope, not for race car. This is more experimentation in electromagnetism.
It's for fun.
And for fun. Yes.
I love watching things spin. I think a lot of people do.
Spin.
think a lot of people like watching things spin fast as long as it's in a safe environment.
Yanni's right. Yeah, it's for generating power. That's correct.
You can generate power with it, but I usually just focus on the one end.
If you set it up correctly, you could probably generate power for like I don't know, maybe a light, maybe computer or something, maybe to charge something.
That would be cool.
Yeah, you can charge. I can charge a battery with some circuitry and a coil. I can charge a battery. I can light a light. I can charge a cat bank.
I'd like to assume that you could charge like an electric car. That's just an assumption. I'm not sure how that works yet.
Probably, honestly. If the battery gets charged the same way any other battery does, I could probably do that.
And I take it you're not sure how to use zooming yet, because earlier.
Yeah, well, it's different than it was before. There's no more.
Well, I know how to use it. I used to do camera, but now I'm just chilling in chat. It's not that fun.
Yeah, it's very good. Yanni's explaining it well.
Thank you, Yanni. Appreciate you.
Robert.
All right.
Welcome to the channel.
All right.
Did you want to plug that in? Oh no.
Yeah.
You had. Did you have anything else to do on it?
No.
All right.
I gotta hook these together in series, but hold on.
Hey everybody, welcome to the channel. Thank you for dropping in. This is the playground right here,
All right, I need to get my sandpaper.
where most of the experiments take place. It's a little rough, but a lot happens here. We got a lot of videos on the channel. Check them out if you can.
Try not to flash the camera on you, please.
And what are you doing here?
I'm getting the enamel off the ends here.
Nice, the enamel. Hi Tony, welcome to the channel.
That looks good.
So Mike asks, is the core a magnet? I'm new to this too.
No, the core is this core is 1018 carbon steel, and it's not a magnet, but it is magnetic.
And then, yeah, we have a lot of different kinds of cores. Definitely iron, a lot of them. And we 3D printed a few a while back. Because that was like iron filaments in the...
Yeah.
Film.
Fused iron fused PLA.
That's it for the 3D printer.
All right. Maybe this will work best through the 32. I don't want to break it, so I'm going to burn it. Those who don't agree with this process, please turn away. All right. So for the testing phase, I think we're going to go smaller for the rotor that it's going to go in. When it's all said and done, it's going in here. And these little brackets is why the core needs to stick out.
Oops. Yep. Hey everybody, welcome to the channel. Thank you for dropping in.
In here, out here.
Yanni said epic, bro. Very epic.
Thank you. All right, so and then testing this is going to be challenge.
So should I call you O.O or can I just call that eyes? Welcome to the channel. Hello. That's awesome.
All right. How am I going to do this? Because this isn't a trigger coil. This is all going to be run. I know I can do it. We'll use our switch here.
Yeah, watch him go to work. This is cool.
Missing stuff. Oh, here we go. Right there. Get it. Blue. Hey. Go to analyze.
Hey Iris, welcome to the channel.
Cool. All right. Now the glue gun's over here. I had to go get a glue stick. All right.
Look at that. That's as far as it goes. Nicely done. Except for burning sensation.
Which rotor do I want to use? I got to use one with cubes in it.
Cubes.
So either the 2-banger or the 9-banger. We'll do the 2-banger.
Thanks, Yanni. Appreciate you. Yanni said, I'm working on the charge controller. So every off on the PWM charger at the FET. I'm trying to oscillate it back also. And it also decouples the secondary battery, so I only need a single battery. Interesting.
I don't know if this one's going to work. I got another one though. This is the newest one that I built. And it's just a piece of copper sticking up, and then it bangs against it like that.
Nice switch.
Let's see now. We're going to make sure everything's going to work.
Yep.
All right, we'll leave the coil where it is. Now, we'll hook up the power. Dang. That was like a Mexican jumping bean. See? Look at that.
Yeah, I was walking in, but yeah.
All right. Now we'll put it in the coil first. Power goes into the coil. The resistance. More connectors. More connectors. All right, and then the power comes out of the coil. Out of the 32 gauge. Into the switch. And then from the other end of the switch to the ground, and then we're good. Simple pulse motor circuit, like the most simple. All right. Now see, the switch might not be. It's making a sound, but it's definitely probably not contacting, because it would definitely make an arc if it was contacting. I got to do better wrapping it around the screw.
Hey everybody, welcome to the channel.
Hey, what's up?
That's awesome, Yanni. Yanni's I need the solar. Trying to get it to detect the signal and adjust dynamically. Switching seems key.
Yeah, I noticed how when you switch faster, you start generating more power. And it's, I believe it's because of, well, at least in this situation, it's because of the magnetic induction that is also occurring. And we got it going. It's going on. And the 32 gauge did exactly what I thought it would. It made it so the amps didn't have anywhere to go. We're getting our little arc. See, this is 12.7 in. Maybe we put too much wire on there.
Sorry, I was looking at it. On the ball.
Yeah, on the end, the little tip part that you put on there. Wow, 20 volts in, no amps being drawn yet. See, and the cool part about it is we can run this 32 gauge coil in parallel. That's as a matter of fact, that sounds really interesting, like a thing we can do right now. So I'm going to turn this off. And I am going going to take this clip out. I'm going to take this black one, I'm going to hook it to this. Now the 20 gauge coil is engaged without the 32 gauge coil, and now I'm going to hook the 32 gauge coil up parallel with the switch and the other coil. Oh, I know that sounds confusing, but it's cool, trust me. Trust me, it's cool. I will back it out a little bit. Yeah, this clip isn't working very well. All right. So this actually has to go here. And then this one goes here. Okay, so now we have our 32 gauge coil and our 20 gauge coil hooked up in parallel, and let's see what happens. Oh, it's going to go the other way.
There it is.
Now that's mainly the 20 gauge coil. Yeah, that's what we want. But the 32 gauge coil is also in action. Now a fuse can happen when the copper gets hot. It'll stick like that.
Mm-hmm.
And then everything's shorted out. You might get more than one contact point there.
Yeah, I saw it like a spark fly.
Like 2 arcs. I like it. 9-volt battery. That's what I'm going to use.
Wow.
Oh, careful, careful. All right, we're going to see how strong this can actually get real quick. Actually, I'll be right back. Okay?
Yeah.
I love how smooth that ride is right there.
Yeah, it'll be 3 over here, yeah.
So I believe it's working at that rate, at that distance,
Mm-hmm.
like pretty well. So that's good. That's a strong magnetic field. Oh, 7.8, no way. 7.8 amps, ladies and gentlemen.
When it's stuck.
When it gets stuck, yeah, that's what this is pulling right here. So reed switch, I don't know. Because if the reed switch gets stuck,
Yeah. It'll fry.
yeah, it'll short out everything and it'll get really hot. All right, I like. But let's take off the 32 gauge engagement thing here. Let's, all right, yeah, that's starting to get hot a little bit. It's warming up. All right, so this goes here like this. And then the stator, of course, will be permanent magnets or electromagnets that are timed with an Arduino or some other form of timing. But this is awesome. These cores and all this is just it's powerful. I want to see how well it'll spin. You can't really put it down without popping the coils out though, because it's designed to sit in a harness or a chassis of some kind that allows for them to rest below the bottom of the rotor. So that's going to be awesome. And then the permag stator that I'm going to use will be at 180 degrees. So that'll be awesome. Have a permanent magnet here and a permanent magnet here. And then let's take that off. I want to spin it and see how well it'll spin. Come on, man. There we go. It's wonderful. I mean, the bearings there are 2 separate bearing sets. I have a 1 1/8 inch bearing with a 1/2 inch hole in the center. Then I have 1/2 inch bearings in that hole to narrow it down to a 1/4 inch shaft. And it's just extra movement there where the bearings meet each other. It's going to be great. And, I still don't know exactly how I'm going to hook it up. It could be in series. but I want each coil to have its own switch, and maybe 2 switches per coil. Maybe it's going to be a normally open and a normally closed switch for each coil. And like maybe 2 paths for each coil. Because when a coil's not on, it needs to be shorted out. And when a coil is shorted out, so there's bursts of energy happening all the time. If the timing's right, you should be able to short out 2 coils and have the other one make it continue to move. I'm really new to the shorting of the coils, but this is going to be interesting to find out how it's going to end up. It's hot in here. Holy smoke. I love this thing, man, already, and it's great. Sweet. So that moves very well. And it glows in the dark too. This rotor glows in the dark. All right. How we looking there, bro? You all right?
I'm tired.
Yeah. So we'll wrap it up pretty soon.
Yeah, about 5 minutes. That's the 9-banger.
Yep. All right, we'll put this coil, nice 1500 turns, a 20 gauge coil right here.
We're going live every other day. Random times. Sometimes he's holding the phone himself. Yeah, and then I can make it in.
I appreciate every little bit of help I can get.
Mm-hmm.
Right.
Oops. Hey everybody, welcome to the channel. Thanks for dropping in. Yeah, check out the channel. We have a couple thousand videos. He's been doing this for a while. Most of them are shorts, but there's a few hundred long videos for sure. All the experimentation, all the learning process. Pretty much from zero to hero.
All right.
What up?
All right.
And it's all documented on the channel.
There we go.
Yeah, it's live.
It's a really heavy rotor. It's got to be like 3.5 pounds. It's a 100% print on the infill, and then it's got 9 neodymium cubes, which adds about 1.5 pounds.
Right on. Thanks for the subscribe, Mike.
So there's your standard 12 volt in.
Upside down. Oh yeah, I can see it. It's bright now. Yeah, you can see it. I'm not even zoomed in, and you can see it, can't you guys? The arc, the little spark there.
Transistor fires way faster, but I mean, it's a different energy flowing through that switch than a transistor. I don't know why, but alright. That's pretty slow though. I gotta admit, that's not going very fast. Seems to be the best spot right there.
Mm-hmm.
It's about 22 degrees off. And that seems to be a magic number for any kind of reed switch. Let's check the voltage on the cap bank real quick. It's been running for a while. So it's up to 4.5. Yeah, I mean, I don't have enough. I need another cap bank, and then maybe I could do the experiment the way it's supposed to be done. But the cap bank loop, the diodes, it would stall out, and without the diodes, it would just eat up all the energy in the cap bank. So it's a bust either way. Until I get another cap bank, and then I can hook my tri-filer coil up, each to their own separate cap bank, parallel, and then have it all dump into the drive battery. You know, have it all go through one, and it's got to be a battery. Let me explain this. You're not going to use a charged up battery to do this. You're not going to use a battery that's 100% brand new to do this. Okay, the battery has to be able to take the energy from the cap bank, but at the same time, it can't run. Well, this is the one that I use to make it work, and it will not run the motor by itself. It will not hold a charge. It's stuck at about 2.5 volts of juice. And what you're supposed to do is you're supposed to take your output and you're supposed to put it through the cap bank, and then from the cap bank it's supposed to go through the battery, and then to the battery it's supposed to go back to the motor. It passes through 2 molecular changes in this process, and for the longest time it was increasing. It was running and increasing. It had 2 diodes in it though. And it had a directional flow. The loop was being guided by diodes, and the voltage would go up while it was running. But then it would stall out when it would get to like 5.3 volts. And I couldn't get it to stop stalling out, so I took the diodes out, and then immediately it ran a little better, but immediately it started draining from the cap bank instead of building the voltage. So, but with 2 cap banks, I don't know, that might be a thing. With 2 coils, that might actually work. Be awesome. All right. Well, thank you very much, ladies and gentlemen. Peace out. Have a wonderful night. Thank you. Please subscribe, like, hit the notification, and stay tuned.
Thank you for coming out tonight.
Bye now.